So this is where our story starts.
Our story begins in 1819 on a sugar plantation in Trinidad owned by Charles Joseph Count de Lopinot. For the most part, the estate was quiet and relatively uneventful. But one day, without warning, the enslaved workers rose up in revolt. Chaos erupted across the plantation as overseers scrambled to regain control.
This is where our story starts. It starts in Trinidad, where there's a unexpected revolt by the slaves. It came out of nowhere, and that's going to be a key part of the story, right? Where there's a revolt and there were no signs of a revolt coming. It just appeared, right? And of course, one of the slave owners here, he's very confused because he didn't expect this to happen. But look at what he's saying. It was not supposed to happen like this. What was she thinking? Who is she in this case, right? Who is he referring to? That's going to be a key part of the story here, right? Right? So the army needs to get involved here.
During the revolt, the owner of the estate, Charles Joseph Count de Lopinot, lost his life while trying to escort his family off the estate. There was a huge funeral service a few days later, and the slaves directly responsible for his death were hung from the huge cashew tree at the center of the estate. To this day, no one knows what sparked the revolt.
All right, so apparently Count Lupino, who is the owner of the Lupino estate, well, he died during the revolt. Okay, it's going to be another key part of the story. So our first question, our first slide starts off where we left off last week on how to bisect a line. How much of you, or by a show of hands, revise this? And I might ask you to kind of look this up and, basically have this clean for today on how to bisect a line. To bisect a line means if I give you a line, like the length of a line AB, bisect means to cut it exactly in half. And last week I showed you, and I will review it a little bit, right? How to use a drawing compass to bisect it or to cut it in half. So what you need to do is take your compass, put it at point A, and you have to extend it. Someone last week asked me a question. How much do we have to open the drawing compass? You're supposed to approximate it in your head and just open it to a little bit more than half. It can be 3/4 of the line, but it has to be more than half of the line. 3/4 is usually a very good estimate, but how much ever you open it to, you have to keep it at that opening for the entire question. So what you would do, you would open your drawing compass and it's pivoted at point A, and you scribe an arc. Keeping the compass opened by the same amount, you now pivot it at point B and you scribe another arc. And of course, the two arcs will meet at point P and point Q. If you take your ruler and connect P to Q, you see this blue line? This blue line will split the black line AB into two equal pieces. This blue line that does the splitting, that cuts the original line AB into two equal pieces, is called a perpendicular bisector. Meaning that perpendicular means the blue line and the black line make a 90 degrees, and bisect means to cut in two equal pieces, to cut it in half, right? And last week I showed you a video, an animation of this process, so I'm going to show you back again, right? Just a set, just to make sure we all on the same page here. So just look over here, just have a look at this video. I won't disturb you for a few seconds. But let's erase any unnecessary information. I'm leaving the A, B, and C, but the values of the coordinates, I think I need to get that out of the way. So here's what you need to do. The first thing you need to do is connect two similar points, okay? You just need to connect two similar points. So what I'm going to do, you could choose any pair of points first. In this question, I'm going to connect B prime to B. So I want everyone using your ruler, don't draw it too dark. Using your ruler and your pencil, I want everyone to connect B prime. Look at it here. Connect B prime to B. That's this red dash line. Come on, do it with me. Connect B prime to B. You could start with any pair of letters. Huh? You could start with connecting A to A prime, B to B prime, or C to C prime. It doesn't really matter. Just choose any pair of similar points. You see that red line? You are going to bisect it using your compass. So what you need to do is put your compass, pivot it at B prime, scribe an arc. You know, open it a little bit more than half. Scribe an arc. And then you're going to put it at B and scribe another arc. But make sure when you open your compass, you do not change the size of the opening. So that means the screw on the compass has to be really, really, really tight. So get your screwdriver and tighten it up. So look at me do it here. Do you all see this? At B prime, I scribed this arc. And then when I went to B, I scribed another arc. Okay? Everyone do that for me, please. And the two arcs should meet here and here. I'm going to give you a few seconds to do that, right? It takes a little bit of skill to do it. Those instructions, again, the first perpendicular bisector, draw a long line through the 2 points. The next one, draw a long line to create the perpendicular bisector. The two perpendicular bisectors will come together at one point. That one point is your final answer. That is the center of rotation. Now, if you're not super neat, you're not going to get the exact answer, right? Right? Let me draw this now. Let me draw my one here. That's my red line and my blue. Well, and the two of them actually come together over here. Now, I did my super neat, right? So my one looking like -5, -1. -5. Look at it, -5, because here's -4 and here's -6. So here's -5, and then lining up with -1 on the y-axis. And that's my final answer. That's the center of rotation. So the procedure here is that you have to join similar points and create two perpendicular bisectors. And the two perpendicular bisectors will meet at a certain point. And that certain point is your center of rotation. Let me know when you're finished, right? If you're a little off, it's because, you know, you need the practice to be neater. That's all, right? I want. Right. So I'm going to give you all 5 minutes to draw this up for me, right? And you all are going to try to find the center of rotation. And I'm going to write back the values on it properly for you. Don't worry, right? Get your graph paper and draw up this diagram neatly for me. This point here is -2, +2. I'll call this point B. minus 1, 4, point C minus 6, 4. Then you have A prime, which is 6, 0. B prime, which looks like 4, 1. And C prime, 4 minus 4. And over here is how you call it, the origin. I want you all to find the center of rotation for me. I'm going to give you a full 10 minutes. But you have to practice it. If you're going to sit back in class and just fold your arms and wait for me, I guarantee you're wasting your time in class. Okay? So 10 minutes, draw, and send the answer for me. Good luck, guys. Let's see. I started, it doesn't matter if you start with the A first or the B first. But I started with the B's first, right? Because it was probably at the top. So I connected B to B prime. And I'm about to make my perpendicular bisector. So I put my compass at B, open it up to a little bit more than half, scribe a decent size arc. Okay? And then I do the same thing at point B prime. Scribe another decent side arc. So the two arcs intersect. You have to scribe the arcs large enough. Like move your hands enough. So the two arcs overlap, right? So it should look something like this. So the two arcs will meet at these two black points here. And of course, I'll use my ruler and draw a perpendicular bisector in a little while. I'm going to do the same thing for A and A prime. So let me connect A and A prime. That's the blue line there. Look at it, the blue dashed line. I connected A to A prime. So I'm focusing on the blue line alone. Going to do the same thing. Open it up to a little bit more than half. Just use my averaging skills to get it to a little bit more than half. And scribe an arc from both sides, from A and A prime. And it should look something like that. I'm going to draw a perpendicular bisector through the two black points and do the same thing through the two blue points. The red line there and the blue line. Both of them meet over here. It looks like the final answer is 3, 5. Confirm it on your graph paper that you got something very close to 3, 5. It should be really, really close to that if you did it super, super neat. And that's the final answer. Continue the story. Remember, it had a slave revolt. And remember, the slave revolt came out of nowhere. So what could have caused it? Well, there are two suspicious guys over here, right? Let's see what's going on.
A few days later, a slave named Martha was walking near the old cashew tree when she overheard two overseers, Jean and Louis, arguing heatedly. They were discussing the recent revolt, lamenting that the cost of it all had become too much to bear. Martha didn't catch the entire conversation, and sensing danger, she quickly slipped away. Slaves caught eavesdropping were often punished harshly.
All right, so it seems that these two guys, Jean and Louise, are arguing. It seems that they have something to do with the revolt, but it's still a sort of mystery. Like, what did they do to cause the revolt? And of course, Martha is the protagonist of the story there. She's in the background, but she didn't hear the whole story. Right? Once again, who is she? They keep referencing this person as she, right? And this person is asking something of them. So we will find out who is she as the story goes along, right?
That night, as rain poured down, two slaves arrived at Martha's hut and dragged her husband outside. Jean and Louis had spread a false rumor accusing him of playing a leading role in the revolt. There was no evidence, but for a slave, none was ever needed. He was taken to the cashew tree, where Jean and Louis personally carried out the hanging.
All right, so it seems that the two guys, the two suspicious guys, John and Lee, they pinned the revolt falsely accused another slave of causing the revolt. Why? Why are they doing this? Right? And of course, Martha is the protagonist of the story. Her husband tells her to run. Right? But unfortunately for the husband, he was not. Okay? So let's see what changes in a little while. Right. Here's another part of transformations. This is called translation. It's a type of transformation. Okay? And it's going to involve horizontal and vertical movements. Remember, we did a lot of fancy things like reflection in the x-axis, a reflection in the y-axis. We even did complex things like rotations and enlargements. Translations is what I call the easy part. So that's good news for you guys, right? This is the easy part of transformations. A slide, a translation, is just like, let me say you have a table. And let's say you have I don't know, a triangle. A slide is just when you slide it to a different point on the table. You don't rotate it, you don't change the orientation, you slide it to a different point on the table. It's literally that simple. But the object always ends up facing the same direction. You notice this one, I put a little dot here. Let me pretend that dot is the nose. When you slide it, the nose keeps pointing the same direction. It's not like a reflection where things end up facing the opposite direction. It's not like a rotation. Obviously, if you rotate something, its orientation changes and things look like it's facing a different what? Direction. So how do we do a translation? If I ask you, if you have an object and I ask you to slide it, and the most obvious question you're going to ask is how much to slide it? Should I slide it 2 feet to the left or 4 feet downwards? Or should I slide it slanted, like move horizontal and vertical at the same time? If you're giving somebody instructions on how to slide something, you might as well give them specific instructions on how much to slide it by. Now, when we're doing translations, there's only two types of directions. It's either you're sliding it horizontal or vertical, or you can do both at the same time, but it's just horizontal and vertical. Anytime you slide something to the right, it's a positive value. If you slide something horizontally left, it is a negative. So on the horizontal movement, you can either slide to the right or you can slide to the left. Right is positive, left is negative. Vertical movements has a similar scenario. If you slide in something vertical, you can either slide it upwards or you could slide it downwards. If you're sliding something upwards, it is considered to be positive. And common sense would say, if you're sliding something downwards, it is what? Negative. When you're writing the horizontal or vertical instructions, you just write it in a pair of brackets like this. The top value will always be the horizontal. H is for horizontal. And the underneath value will always be the vertical instruction. V is for vertical. I want everyone to take down everything on the screen here, exactly how I have it. I know it's scrap paper I'm asking you to write it on. Write it on scrap paper. And you're going to have to constantly reference it now. So that's why I want it on a piece of scrap paper so you could see it right throughout class. Okay? Right. Right. So here we have a triangle. I'm not going to ask you to draw it. You can just use my screen to figure it out. Let's call this point E, and let us call this A prime. Let's call here B, and here what? 1 second. Call here B, and here what? B prime. Call here C, and C prime. Okay? All right, sorry, I just sneezed there. All right, now doesn't this triangle, we start off with A, B, and C. Doesn't it look like it's slide? It looked like it just somebody just took their hand and kind of slide it diagonally upwards. We want to figure out what translation caused this. Whenever it's a slide, it's a translation. So they're asking us for the value of the translation. Like you ask somebody, okay, so somebody comes up to you and said, hey, I noticed how you move A from, sorry, the first triangle to a different position. And you start to get more technical now. The person said, yeah, I slide the triangle upwards, diagonally upwards. And the person says, okay, I understand that you slide the triangle diagonally upwards, but could you be more specific? Like, but by what value did you slide it vertically upwards? You gotta get mathematical now, no. Just saying that you're sliding it upwards. In other words, if you slide a triangle upwards, like you tell somebody that over the phone, and they can imagine that so many different ways. They can imagine it going like this, or like this, or like that. All of them shows a person sliding it diagonally upwards, right? But when you're specifying something in maths, you have to be super, super accurate. So I'm going to show you how to give a mathematical value on this. All you have to do is take any pair of points. It could be A, or it could be B, or it could be C. Really, really doesn't matter. I'm going to choose A. How did point A move? We only allowed to walk horizontal or vertical. So if I'm standing at point A, I'm going to have to move 1, 2, 3, 4, 5. Everyone agrees that I have to move 5 horizontally. And when I reach there, I have to move how much vertically? 1, 2. Does everyone agree with me that if I am trying to walk from A to A prime, and I'm only allowed to walk vertical and horizontal, then I have to walk 5 places to the right and then walk 2 places upwards. You always do the horizontal movement first. So I move 5 spaces to the right. So I'll write 5. I'm going to write it in pink, sorry. Well, that's horrible handwriting there. Ugh. And then I have to move how much spaces upwards? 2. So my translation, by the way, I have to put the horizontal value on top and the vertical value underneath. Should the horizontal value be positive or negative? In other words, should I put positive 5 here or negative 5? Which one are we going to put there? It should be positive 5, right? But remember, if you look back in your scrap notes, when it's a horizontal movement, if you walk to your right, it is considered a positive value. I don't have to put it positive because the positive is understood. And once we reach over here, I have to move 2 spaces vertically upwards. Upwards movement is positive. So that's my answer. 5, 2. 5 on top, 2 underneath. Simple, right? There's no multiplication here today. You know, remember last week it had a lot of multiplication of matrices. Today, it's pretty simple. It's way simpler than that. Okay? And that's the answer. That's the value of that translation. The value of the translation is the mathematical value of the slide. So on the phone, instead of saying you slid the triangle diagonally upwards, You could say, hey, I performed a translation, also known as a slide, of a value 5.2. And the person on the other side of the phone will be able to imagine exactly how much that slide was, right? 5.2. By the way, I just let you know, if you wanted to reverse the process, then this may be obvious, right? But I'm still going to say it, right? If you wanted to reverse the process, let me say you were starting at, let me just say you was starting at E, like you wanted to go backwards. You wanted to put this triangle back to the original position. If you're starting over here, then you would have to move instead what? 1, 2, 3, 4, 5 to the right, to the left, sorry. If you're moving to the left, it will be -5. And once you reach here, you have to move down by how much spaces? 1, 2. So since you're moving down, it will be -2. Whenever you're reversing a translation, like you want to go, like slide it back to the original position, the values just become the opposite. You notice +5 become -5 and +2 become what? -2, right? But I know to most people that would have been obvious, but I just wanted to make sure that I cover all my grounds. So how much of your like translations, the sliding questions, more than last week's questions with the rotation and reflection and enlargements, right? And here's the good news, translations, the easy questions, are just as popular as the hard questions. So maybe for the exams, you'll be lucky, right? You will get what? The easy types of questions. I hope you do. Let's move on. All right. I want you all to find the translation value for me here. You have to use well, I'm not asking you to draw it. I'm just asking you to put your eyes close to the screen. This is clearly a slide. Like it's, by the way, this is a starting point here. Just now, right? This will be a start, the original, and this one will be a finish, right? Figure out the value of the slide to move in that direction. Send the two values for me, and I need the signs. If it's positive, I want you to tell me if it's positive. If it's negative, I need to know if it's negative. You could choose any two similar points. Any two similar points will give you the same exact answer. You choose. Give you 2 minutes. Like I said, anyone's going to give you the same answer. I'm just going to choose this one up here, and of course, its similar point is down here. How much did I have to move? 1, 2, 3, 4, 5, 6. So I moved to the right, so that should be +6. And then I had to move how much down? 1, 2, 3. But I'm moving downwards, so that's -3. The final answer would be what? +6 -3. And a lot of people had that on the chat. All right. +6 -3. Easy stuff. And I just saying, if you wanted to reverse the process, you don't need to go back and do your work, you know. Like if you wanted to slide it back to its original position, you don't have to go and count back the blocks. You just have to look at each value here and make it the opposite. So if you wanted to reverse the process, +6 would be -6. And -3 would be +3. Right? There's no need to go and count the blocks again. I'm telling you, you're going to end up getting the opposite answer. That is all you're going to help it. Right? Right? All right, let's continue. Right, so Martha is obviously very, very sad here. Her husband was just found. And for no reason, she didn't get a proper reason.
Every day for the next year, Martha visited her husband's grave, mourning in silence. In her heart, she vowed that one day she would have her revenge. Whispers among the slaves spoke of a spirit named Gangang Sarah, said to appear by the river beneath a blood-red moon. According to legend, she would help slaves seek vengeance, but always at a price.
All right, so this is where the legend of Gangang Sarah. For those who are really interested in reading up on it, when your class is finished, you can read up on Gangang Sarah, right? It is usually it's a spirit according to folklore that people usually, when they want something, they go to Gangang Sarah. And of course, they strike a bargain with this spirit. And of course, you know how stories like this end up. You make a deal with a spirit. What they want in return is probably more than you could afford, right? They don't usually turn out too well, okay? So, but Martha doesn't care. She's at the end of her ropes. She wants revenge, right? Can't blame her, right? So,
One night, Martha took a chance and slipped quietly out of her hut, determined to find Gangang Sarah. She made her way to the river and waited patiently beneath the moonlight. Before long, the spirit appeared, her eyes glowing, her form hovering just above the water as she drifted toward Martha. In a voice that seemed to echo through the trees, she promised Martha her revenge, but warned that it would come at a price.
all right, so Martha goes to the river where the other slaves saw that where the legend is Gangang Sarah will appear over there. So she appears, if you look at her, she's hovering over the water, eyes glowing, and then she approaches Martha. Right? So that's the conversation they have. All right? Let's go. All right, we'll see how this turns out. Right? All right. I want you all to try to figure out the answer for this question. I'll give you some advice on how to do it, right? I'm going to call this point A, right? And this point is minus 3, 3. I'm going to call this point B, which is minus 2, minus 3. I want to make sure, minus 2, minus 3. And point C, minus 5, minus 2. I come now in the exam, pretend I'm the person in the examiner, and I say, I want you to perform a translation. I want you to slide this triangle by this amount. So I'm not only telling you to slide the triangle, I'm giving you specific instructions on where to slide it to. Obviously, if you slide this triangle to a different point, the A, B, and C values will change, right? Because you're sliding it to a different point on the graph paper. My question to you is, what would be the new A point? What would be the new B point? What would be the new C point after it slides? I want you just to try the question, right? You don't have to get it correct, but I want you to give it a genuine try. Let me see what you come up with, right? I want to see what you come up with. All right. We have the point E. Let me start off with E. So E, when you're trying to figure out A prime, right? All you have to do is take point A. How much is point A? Minus 3, 3. But when you're writing it, write it vertical. The X coordinate will go on top and the Y coordinate will go underneath. Write it vertical. And all you have to do is add, always add the translation. How much is the translation? 6 minus 2. And if you work this out, you will get A prime. You add the top to the top, you add the underneath to the underneath. Now, this is where the work from Saturday class, the Form 1 and Form 2 class, comes into play, right? Remember, I invited everyone in this class today, Saturday maths class, so they can learn the basics in addition and subtraction of positive and negative numbers. Minus 3, you're adding the top to the top, eh? Minus 3 plus the 6 from the translation gives you positive 3. 3 plus minus 1, a plus and a minus is a minus. So you end up with 3 minus 2 is 1. So point A prime, the top is X, the underneath is Y. Where's 3, 1? 3, 1. A prime will be here. Now you can do it this way also. Since the top was positive, that means you move to the right 6 spaces. And if the underneath value is minus 2, then you move it down by 2 spaces. Was that correct? Look at it. If I'm starting at 8, you move 1, 2, 3, 4, 5, 6. And when you reach here, you move down by how much? Because it's negative 2. 1, 2. You would still end up with 3, 1. You would still end up at that position, whether you decide to count it physically or you just apply the translation and add it to the point. Either way, you're going to get the same exact value. So see if you can do B for me now. And you could probably do B with the calculation, and then you can practice with C by counting the physical blocks. The point is, all the points are moving 6 spaces to the right and 2 spaces downwards. See if you can finish off the question there, right? Don't overthink it. I think some of you think it a little harder than it needs to be, right? Because the past weeks we've been doing hard stuff. So your brain telling you, hey, this is supposed to be hard. No, this is the easy part. To find the new position of B, which is B prime, the original B point is minus 2, minus 3. I write it vertical. Look at that, minus 2, minus 3. Then we are going to apply the translation. 6 minus 2. The top is for the top, the underneath is for the underneath. Minus 2 plus 6 is positive 4. Minus 3 plus minus 2, a plus and a minus is a minus. Minus 3 minus 2 is minus 5. So it looks like B has moved to 4 and goes all the way down to minus 5. B prime. 4 minus 5. And I said we could do C by the counting method, right? If you wish. So if the translation is positive 6 minus 2, then we move it 6 spaces to the right and then move it down by minus 2. 1, 2, 3, 4, 5, 6. And then we move it down by how much? 1, 2. This looking like 1 minus 4. And if we connect this up, it should look something like this, right? Not all the answers were correct, but for the people who got it correct, congrats. And for the people who didn't but tried, still congrats. Okay. Fun. Easy stuff, right? Easier than... All right, so this is where it's going to get a little bit hard. We finish with translations, right? With translations. That's his slide. Sometimes when we're doing this topic, right, you have to do more than one things at the same time. For example, we've been doing a reflection in the x-axis. We did reflection in the y-axis. We did enlargements. We did rotations. We even did slides. But you notice when I was asking you to do those things, it was always one at a time. Like, for example, one question would be rotate it by 90 degrees. And that was the end of the question. Or reflect it in the y-axis. And that was the end of the question. But sometimes they can ask you to do things like They can ask you to do more than one things at the same time. It's like this. Somebody says jump, so you jump. Somebody says do a flip, so you flip. And somebody asks you to run, so you run. But then somebody can ask you to run and do a flip. They're asking you to do two things at the same time. You're running, and so you're doing a running flip, which means you will flip further. The same thing over here. In this question, I'm going to ask you to do two things. To reflect something in the y-axis, and at the same time, you're going to have to enlarge it by a factor of 5. So you're not only reflecting in the y-axis, you're reflecting it, and it's getting larger at the same time. So in other words, you're killing two birds with one stone. You're combining actions now. To do that, you have to be able to multiply matrices real good. Have you all so far in this class have I shown you how to take a big matrix with 4 numbers and multiply it by another matrix with 4 numbers? The answer is no, right? This is what you have done so far in matrices. Like, I would have given you one big matrix, say 5, 2, minus 1, and 3, and I would have asked you to multiply it by a small matrix that only had 2 values. I'm going to put 2 and 1 here. I want you all to, just as a refresher, take this big matrix, which has 4 values, and multiply it by a small matrix with 2 values, and send the answer for me. Just as a refresher, do it on scrap paper. This is the one where Batman swings up to the top and whatnot. Okay? Those 2 ones. So this one here, when you take a big matrix and multiply it by this, you're supposed to get 12 here. And that's our 1. 12 and 1. And the answers are coming up on the chat. It's 12 and 1, eh? Gordon, check it back. Remember, you end up with minus 2 plus 3. Remember, this is minus 1. You're supposed to get positive 1 here. Okay? Great. Right. So by now taking a big matrix and multiplying by a small matrix, it's supposed to be easy. So the question is, how do you take a big matrix and multiply it by another big matrix? Real simple concept here. You see the second matrix? I want you to split it into 2, right? Just split it into 2. And all you have to do, think about it like this. The second matrix, if you split it in 2 and you forget about these 2 values here, and you all could take this and multiply by minus 1, 0, isn't that a regular boring question? Do that for me. Take the first matrix and multiply it by the first 2 vertical values. You will get 2 answers. I want you to put your 2 answers here. Just do that for me. Take 3003 and multiply by minus 10. You will get 2 answers. Write the 2 answers over here. You're repeating the Batman process. Right? Send it for me. Answers you are supposed to get is minus 3 and 0. That's these 2 here. Now, here's what you're going to do. You're going to repeat the process. You see how you take the matrix in front and multiply by the first 2 values? Don't pay attention to the first 2 values now. Pay attention to the next 2 values. So take the same matrix now and multiply by the second pair of vertical values. And you will get 2 answers here. Get these 2 answers. You're repeating the process now, right? In other words, when you take a big matrix and multiply by another big matrix, you get 4 answers. The first 2 over here give you the first 2 answers. Then the second answers over here will give you the other 2 answers. right? So this is really two small questions merged into one big question. Right? So get the two answers for me, and that will be the end of that question. The two answers you're supposed to get is 0 and 3. 0 and 3. Right. So let me show you the point of all of this now. The examiner comes and says, hey, I want you to create a matrix that will do two things for me at the same time. It will reflect the object in the y-axis, and then it will immediately afterwards, that's what the word then means, it will enlarge it by a factor of 3. Now, one of these things was mentioned first, and one of these were mentioned second. Now, that's very, very important, right? If I ask you to jump and flip, that's different from flipping and then jumping. The order matters. According to the examiner, right? Which one does he want you to do first? He wants you to reflect it in the y-axis. And after you reflect the object in the y-axis, he wants you to enlarge it by a factor of 3. Notice something very, very strange. Whenever you're trying to do two things, right? And what you're trying to do, you're trying to create one matrix that will do two things at the same time. Does everyone agree that this matrix here is an enlargement by a factor of 3? Confirm it with me. Go back in your notes. Does this matrix do an enlargement by a factor of 3? Yes or no? Does that one? In your notes, you should see something like this, K00K, where K is the enlargement factor. And the answer should be yes, right? You will see that in your notes. And is this one here a reflection in the y-axis? Is -1, 0, 0, 1 a reflection in the y-axis? And the answer is yes, if you look back in your notes. But you notice that when you're trying to combine these two matrices to get one matrix that will do both things for you, you'll notice that it goes against common sense. And the first thing that the examiner wanted you to do was reflected in the y-axis. So why did we write? Look at the order. When you're combining matrices, we combine it in the opposite order. Most people would do it like this. If you want to make one matrix that will reflect something in the y-axis and then enlarge it by 5, they would have say, all right, the first thing the examiner wants me to do is reflect it in the y-axis. And then most people would, by default, would put it in this order. But when you're combining matrices, you just have to do it in the reverse order. The second thing, you just put it first. And the first thing, you just put it second. Don't even bother to think it through. That's how you do it. Whenever you're combining matrices to give you one matrix that will do both things at the same time, you have to combine them or multiply it in opposite order. The second thing goes first, and the first thing goes second. It goes against common sense. Everyone understands that? Also, this is a time saver, because if the examiner wants me to reflect something in the y-axis and then enlarge it by a factor of 3, if it was a triangle, I would have to do 3 pieces of calculation, one for each point here, and then 3 pieces of calculation over here. That's 6 calculations in all. Or I could just get this matrix, which is only one calculation when you get really good at matrices, And then I could take this one matrix and visit each point. And that matrix will do this and this at the same time. So you reduce 6 calculations to only 4 calculations. One calculation being getting the matrix itself, and then you apply the super matrix, I call it the super matrix, to each individual point of the triangle. That's 4 calculations in all. You reduce 6 to 4. Right? Now, this takes a little bit of practice, right? Now, I know it's coming to the end of class. I know it's coming to the end of class. And this is where people begin to get tired. They begin to get mentally tired. And don't worry, next week is our last maths class. We still have one more maths class, guys. We still have one more. I'm going to start class with this next week. Refresh your memory. And then I'm going to show you how to apply it. But at least you got an introduction today. All right? So here's what, guys. For those who want to see the end of the story, it's quite a lot to go. It have about 6 or 7 slides to go through. I know some of y'all don't care. No offense taken. That's okay. If you want to leave, you can. But for those who just want to see the end of the story, feel free. Stay back. It'll be a little cinema. Right? A little mini cinema for you guys. So for those who want to leave, feel free to leave. And for those who want to stay back. You'll have some fun. All right. So Martha, remember Martha went into Gangnam Syrup. Promised her bench. Now Gangnam Syrup makes things happen. And people don't know why it's happening, but it's the work of Gangnam Syrup.
The next day, Lewis was walking through the bush, hunting for deer, when the air suddenly grew oppressively warm. A swarm of insects began to buzz relentlessly around him, clinging to his skin and clouding his vision. Unnerved and sweating, he decided to head to the river to bathe and cool off, hoping the water would wash away the heat and the persistent bugs.
All right, so it seems that the place just mysteriously got hot out of nowhere, right? And there's Louise, one of the bad guys responsible for Martha's husband's death. So obviously, what he's going to do, right? He's going to rush towards the river to bathe off quickly, right? To get rid of the bugs.
As Lewis reached the riverbank and stepped into the cool, shallow water, sighing with relief. But just as he bent down to splash water on his face, something shifted in the reeds nearby. Before he could react, a massive anaconda lunged from the undergrowth, wrapping itself tightly around him. He thrashed and gasped, but the serpent's grip only tightened until, at last, everything went still.
All right, that's the anaconda, but the work of Gangnam Syrup. So Louise is gone, right? That's half of her revenge set into motion. Let's hear the scream again there. That's free song effects, right? So there's the question of Jean still, right?
When Lewis didn't return by nightfall, Jean assumed he had wandered off drunk and passed out somewhere. As the storm rolled in, Jean grabbed a lantern and set out to look for him, starting near the barn. While checking the animal's water tray, he froze. Reflected in the rippling surface was a ghostly pale face of Martha's husband.
All right.
Terrified, Jean dropped the lantern and bolted blindly into the rain, unknowingly running straight toward the giant cashew tree.
All right, so remember, Jean, well, his sort of friend, went looking for Louise now because he's missing. But while looking for him, Martha's husband her face appears in the stream, and it frightens Louise, right? He's scared out of his mind, and he runs through the rain, right?
Jean sprinted through the downpour, lightning flashing across the sky as thunder shook the ground beneath him. His boots slipped in the mud, but he didn't stop until he reached the towering cashew tree. There, drenched and gasping for breath, he suddenly froze. His eyes widened, and his mouth fell open in silent horror. Something stood before him, something the storm could not wash away.
So what did he see? Right? Why is Louis like that?
Then, through the storm's fury, he saw him, a figure on horseback, emerging from the mist like a shadow from another time. It was Charles Joseph Count de Lopinot, his face twisted with rage, wearing a dark coat and holding a gleaming sword. The ghost of the long-dead plantation owner raised the blade high, and with a swift, brutal motion, he struck. Jean barely had time to scream before the sword fell, ending his life in a flash of cold steel.
All right, remember Count Lupino from the beginning? But his ghost came back. So the ghost, that's him there. You have to love that scream. Right. So Louise is gone. So Martha has her revenge. Right? But the story is not finished. Now remember, Martha made a deal with Gang Sarah. Right?
With revenge complete, Martha went back to the river the next night and met Gang Sarah ready to pay the price. Her heart pounded as she hoped the price would not be too high. Gang Sarah told she would pay with her life, as the price for to take a life was to pay with one, and she would live until the next full moon. Martha's face went pale. The spirit then smirked at her fear and then offered an alternative.
You all realize Louise and John made the same deal with Gang Sarah. You can have your revenge, you can have anything you want, but in return, you have to take a life. So Martha falls into the same trap as Louise and John. Clearly, Gang Sarah here is a kind of trickster, right? A person who, you don't make a deal with them, right? So Martha, to repay the debt, has to take a life in return, right? What will Martha do now? She's in a little bit of a pickle here, right? But the deal has already been made.
A few weeks later, Martha's best friend, Jane, was found by the river by one of the overseers. Jane had been drowned in the river under suspicious circumstances. Martha had planned it perfectly. Jane and her husband had a huge public argument the night before. Martha then invited Jane to meet her by the river to console her. Naturally, everyone suspected the husband and he was hanged without much consideration.
All right, guys, it seems that Martha didn't recover, right? So her best friend met her end, right? So let's see what happens in the end here.
The year is 1960. Slavery has long been abolished, and Martha, now an old woman with silver hair and tired eyes, lives a quiet life in a small wooden house nestled in Morocco's valley. She has since remarried, but some wounds never heal. Each day, she steps onto her veranda and gazes up at the sky, her heart heavy with regret. She silently prays that the universe might one day forgive her, and that she had never crossed paths with Gang Sarah.
And that's it, guys. That's the end of the story. Not the happiest ending in the world, but it's still an ending. All right. So, guys, I really hope you all enjoyed class today. I hope you enjoyed the work, you understood the work, and more importantly, I hope you all enjoyed the work. So, see you all next week, guys. See you all next week. And some of you all have English after at 11:30. So, hope to see you all there. Take care, guys. Have a good one.